So now we're going to start the discussion about the general embryology. Okay. See, from general embryology, we are getting one questions in the NEET, INACT exams. Okay. Now the questions can be direct general embryology question or they can club with OG. Okay. But the point is, yes, you get one question for sure. Now to begin with, we're going to start the discussion about the gametogenesis. So before seeing the first week development, second week development, third week development, we need gamete. So first we're going to discuss gametogenesis, okay? And then we're going to see the first week, second week, third week development. Yes. Now for the synthesis of gamete, we need one special cell called primordial germ cell. It is the cell which produce the male gamete and the female gamete. That is why they have given the name primordial germ cell. Primordial germ cell, which is synthesized by, which is given by, produced by the epiblast cell. So primordial germ cell derived from epiblast. It is derived from epiblast during second week. So this is a primordial germ cell. Okay. Now this primordial germ cell and then migrate to yolk sac and then migrate to yolk sac by fourth week. Okay. Finally, they migrate to gonads by fifth week. Gonads means genital ridge. Genital ridge. That is the future gonad. They go into the gonad by fifth week. Okay. Now, this is the story of the primordial germ cell. So, primordial germ cell derived from epiblast during second week. So, second week in the sense, the second week is called embryonic period or pre-embryonic period or fetal period. So, by the side, you please put one box and then write pre-embryonic period. Pre-embryonic period is from 0 to 2 weeks. Embryonic period is from 3rd to 8th week. Fetal period from 9th week till birth. From 9th week till birth. That's a fetal period. So pre-embryonic period, embryonic period and the fetal period. So pre-embryonic period 0 to 2 weeks. Embryonic period 3 to 8 weeks. And the fetal period from 9th week. Okay. Yes. So now, yes, the primordial germ cell, it is coming from epiblast during second week. That is in the pre-embryonic period. Okay. And then migrate to yolk sac by fourth week. And finally reach the gonads by fifth week. Now, this primordial germ cell, see here, they're migrating. Use a yolk sac. From the yolk sac, they're going to the, this is yolk sac. Now, from the yolk sac, they're migrating to the genital ridge, the future gonads. Okay. Now, the primordial germ cell, it is the pluripotent cell. It is the pluripotent cell. Pluripotent cell means they have ability to form all the germ layers. They have ability to form all the germ layers. All the germ layers. Okay, that is our primordial germ cell is our pluripotent cell. So now we're going to see some more terminologies. Now, number one, totipotent cells. So totipotent cells means they have ability to form. They have the ability to form the entire embryo and the extraembryonic tissue. On the extraembryonic tissue. Okay. So up to 8 cell stage. Up to 8 cell stage, each cell is having the totipotency. Okay. Next, multipotent cell. Multipotent cell means they have ability to form more than one category of cell. More than one category of cell. Okay. Example, hematopoietic stem cells. Yes. You know the definition, no? Next, oligopotent cell. Oligopotent cell, they form one category of cell. They form one category of cell. Example, vascular stem cells. Yes. Next, unipotent cell, they form only one type of cell. They form only one type of cell. Example, hepatic cells, liver cells. Okay, they form only liver cells. So these are the examples. The terminologies, sometimes you may get, okay, very rarely you get, but try to know the difference between these. Okay, I told you the primordial germ cell, it is a pluripotent cell. They have ability to form all the germ layers. Okay, now sometimes instead of going to the gonads, the primordial germ cell, it may go to the region between the head and the neck. Okay, in that case, it is producing teratoma. Now the question is, why teratoma? So I told you the primordial germ cells, pluripotent cell. Now instead of going to the gonad, it is going to some other regions. So in that case, it is forming teratoma. Clear? Sometimes it may go to the region between sacrum and coccyx. In that case, it is forming sacrococcygeal teratoma. Again, why teratoma? Primordial germ cell, pluripotent cell. They have ability to form all the germ layer, ectoderm, endoderm and mesoderm. Okay, so please write abnormal migration of primordial germ cell results. Abnormal migration of primordial germ cells results in teratoma. Is that clear? So abnormal migration in the sense, instead of going to the gonads, it is going to some other region. Okay, so abnormal migration of the primordial germ cell to the neck results in craniopharyngeal teratoma. Craniopharyngeal teratoma. Okay, abnormal migration of primordial germ cell to sacrum and coccyx. First one neck, second one to sacrum and coccyx results in sacrococcygeal teratoma. Clear? Abnormal migration of primordial germ cell to sacrum and coccyx results in sacrococcygeal teratoma. Okay, now the sacrococcygeal teratoma, it is due to two reasons. Now the sacrococcygeal teratoma is due to two reasons. First reason we know, abnormal migration of primordial germ cell. Abnormal migration of primordial germ cell. Okay, number two, persistence of primitive streak. Persistence of primitive streak. Sir, we have a doubt, sir. What is primitive streak? Don't worry, you write now. We are going to discuss about the primitive streak later. I'll tell you. Now, meanwhile, please write this tumor, sacrococcygeal teratoma. It is a tumor due to two reasons. Number one, abnormal migration of primordial germ cell, and number two, due to persistence of primitive streak. Primitive streak we see later. Don't worry. Meanwhile, they gave this question in 2018 DNB exam. Okay, same national board only set the paper for the NEET exam. So they may ask you again in the coming NEET or INCT exam. Okay, this is the tumor between the sacrum and coccyx, that is our sacrococcygeal teratoma. Okay, and similar image, see with this idea and background, 2023 November INCT we got the question, image based question we got. Recent INCT exam question. I told no, one question will be there from this topic, general embryology. Gametogenesis, first week, second week, third week, placenta. Yes, from these 4 to 5 topics, you get one question for sure. Okay, so with this idea and background, they gave one question in the last November INCT exam. Okay, so these are the points you have to know. Now next we're going to start the discussion about the oogenesis and the spermatogenesis. Now before that, we have to know some basic points about the cell division, mitosis and meiosis. So we're going to write the difference between mitosis and meiosis. Some basic points only. Mitosis and meiosis. Now what is mitosis and what is meiosis? Now if you have 46 chromosome, the same 46 is given to the son and daughter, that is called mitosis. If you have 46 chromosome, if it is given as 23, then that is called meiosis. So mitosis is equational division. The chromosomes are equally divided. Meiosis, the chromosomes are reducing into half. It is called reduction division. Okay, mitosis is equational division, meiosis reduction division. Next one, mitosis. It takes place in the body cells. Mainly, it takes place in the body cells. takes place in the body cells, whereas meiosis takes place in the germ cells. Okay. Next. Now, the mitosis, here no crossing over. So here in meiosis, crossing over takes place. Crossing over means the exchange of the chromosomal material. The exchange of chromosomal material. Okay. So by this, the daughter cells, they do not resemble the parent. They do not resemble the parent. Okay. Right. Because of crossing over, there is exchange of chromosomal material. The daughter cells do not resemble the parent. Now, meiosis in female, it starts in the intrauterine life itself. Meiosis start in the female intrauterine life itself. The meiosis will start. Whereas in the case of male, the meiosis occurs only after puberty. In male, the meiosis process start only after puberty. Only after puberty. This is very important. In 2020 NEET exam, they gave true or false statement. In that, they gave question: meiosis in male starts. Meiosis in male starts on the pre-pubertal testis. Likewise, they gave the question. So pre-pubertal testis, meiosis will start. No, in male, the process meiosis will start only after puberty. So pre-pubertal testis, the meiosis will not start. Only after puberty, the meiosis will start in male. So we see the spermatogenesis later. So don't worry. Now these are some basic difference between mitosis and meiosis. Now with this idea and background, now we're going to see the oogenesis. Okay. So now we want to start oogenesis. Okay. So now oogenesis, the primordial germ cell reach gonads, ovary. Now the primordial germ cell converted to oogonium. So after reaching the ovary, the primordial germ cell converted to oogonium by mitosis. Now the oogonium by mitosis, it is converted to primary oocyte. Now by 5th to 7th month, all oogonium converted to primary oocyte. By 5th to 7th month, all oogonium converted to primary oocyte. Now, this primary oocyte enters meiosis 1 and completes only prophase. It is completing only prophase. After completing the prophase, it goes to resting phase. That is called diplotin phase. And then it goes to resting phase. That is called diplotin phase. Okay. Now, after completing prophase, metaphase will start. Yes or no? Prophase, metaphase, anaphase, and telophase. So after completing the prophase, it is not going to metaphase. It is going for resting phase. That is called diplotin phase. Okay, sir. It will take rest for 1 day or sir. No, it is not taking rest for 1 day. 1 month? No, it is not taking rest for 1 month. It is taking rest until the girl attains puberty. It is in the resting phase until puberty. That is the point. So the primary oocyte, after completing the prophase, it is going to resting phase. It is in the resting phase until puberty. Clear? Okay. Now after puberty, the meiosis start. The meiosis 1 will start. Already started. In the completed only prophase, meiosis 1 will resume, which in turn forms secondary oocyte. It completes meiosis 1. After puberty, you can write like this, which completes meiosis 1 and form secondary oocyte and first polar body. See, polar bodies are the cell without cytoplasm. Polar bodies are the cell without cytoplasm. So during cell division, all the cytoplasm will go to secondary oocyte. All the cytoplasm will go to secondary oocyte. Polar body does not receive any cytoplasm. So the polar bodies are formed due to unequal division of cytoplasm. So polar bodies are formed due to unequal division of cytoplasm. Unequal division of cytoplasm. So polar bodies are formed due to unequal division of cytoplasm. Okay, all the cytoplasm goes to secondary oocyte. Polar body does not receive any cytoplasm. Now here, the secondary oocyte now enters meiosis 2. Enter meiosis 2. Now here, which completes prophase and metaphase. Which completes prophase and metaphase. After completing the metaphase, which goes to metaphase arrest. How long, sir? Now the metaphase arrest only for 24 hours. How long, sir? For only 24 hours. Okay. Now it is waiting for, yes, sperm. So within 24 hours, the sperm entry. Then what will happen, sir? So secondary oocyte completes metaphase, and it is a metaphase arrest for how many hours? 24 hours. So now the Graafian follicle rupture. Now the Graafian follicle rupture and release the secondary oocyte. That is ovulation. Okay. Now Graafian follicle rupture and release ovulation. So now the secondary oocyte is released. Okay. Now the secondary oocyte in the metaphase arrest. I told you already, the secondary oocyte will be available in the metaphase arrest only for 1 day, 24 hours. So within 24 hours, there is a sperm entry. What will happen, sir? Sperm entry is positive. Then what will happen? The secondary oocyte completes meiosis 2 and form ovum and the polar body 2. Okay. So within 24 hours of metaphase arrest, now the sperm entry is positive. Now the secondary oocyte completes meiosis 2 and forms ovum and polar body 2. Now this ovum fuse with sperm and form zygote. Clear? Yes. Now this fusion is called fertilization, and zygote also known as fertilized egg. Okay. So this is the case if the sperm entry within 24 hours of metaphase arrest. I told you already, the Graafian follicle rupture and release the secondary oocyte in the metaphase arrest. So now after the rupture of the Graafian follicle converted to corpus luteum. So there is no sperm entry. So now there is no sperm entry within 24 hours of metaphase arrest. Within 24 hours of metaphase arrest, what will happen? I told you already, the Graafian follicle rupture and release the secondary oocyte in the metaphase arrest. After the rupture, the Graafian follicle converted to corpus luteum. Then the corpus luteum after the rupture persists for another 14 days. And then shrink and forms a white scar. And then it forms white scar that is called corpus albicans. Okay. So if there is no sperm entry, so then the corpus luteum persists for another 14 days and then forms a white scar called corpus albicans. So only in the case of sperm entry, the meiosis 2 will complete. Okay. Completes meiosis 2 within 24 hours of metaphase arrest. That's very important. Okay. Right. Now next. So we're going to see spermatogenesis. Spermatogenesis. That's all about oogenesis. Oogenesis over. Now the primordial germ cell reach testis. Okay, I told you meiosis, the process will start in male only after puberty. Now the primordial germ cell, after reaching the testis, it goes to dormant phase. It goes to sleeping mode. It will be in the dormant phase. How long, sir? It is a dormant phase until puberty. So nothing will happen up to puberty. In the case of male, the primordial germ cell go to testis. After reaching the testis, it go to sleeping mode. It will sleep. How long, sir? Until the boy attains the puberty. Now only after puberty, the primordial germ cell converted to spermatogonium. So only after puberty, the primordial germ cell converted to spermatogonium. Now the spermatogonium, after the mitosis, it is converted to primary spermatocyte. So here we have written the spermatogonium converted to primary spermatocyte by mitosis in a single step. Actually, many structures are formed in between. The spermatogonium forms type A dark cell and then type B dark cell. So various cells formed in between the spermatogonium and the primary spermatocyte. Again, that is not worth mentioning. So we simply written a single step. But please remember, spermatogonium converted to primary spermatocyte in 5 to 7 cycles of division. So spermatogonium converted to primary spermatocyte by 5 to 7 cycles of division and then form the primary spermatocyte, spermatogonium. Not in a single step. 5 to 7 steps are involved. Okay. That is not necessary. So we are simply leaving that. Okay. Now this primary spermatocyte, by meiosis, it is converted to 2 secondary spermatocyte. Then each secondary spermatocyte, again by meiosis 2 forms spermatid. Okay. So the secondary spermatocyte by meiosis 2 forms 2 spermatid. Now spermatid undergoes one special process called spermiogenesis. Spermiogenesis is nothing but it is a last final touch-up work, rearrangement of the organelles. It is nothing but it is a rearrangement of the organelles, one last final touch-up work, like rearrangement of the organelles. Now by this, the spermatid are converted to spermatozoa. Okay. So the secondary spermatocyte forming spermatid, the spermatid undergoes one process called spermiogenesis and form the spermatozoa. Now arrange the structure formed sequentially in the spermatogenesis event. So first spermatogonium and then spermatocyte and then spermatid and then spermatozoa. Clear? First gonium and then spermatocyte, primary, secondary, and then spermatid and then spermatozoa. Arrange the structure sequentially. Okay, 2019 and 2022 INACET, 2019 AIMS exam and 2022 INACET, we got this question. Repeat question. Okay, right. So now one primary spermatocyte forming 2 secondary spermatocyte. Each secondary spermatocyte forming 2 spermatid. Altogether, one primary spermatocyte forms 4 spermatid. Right. Now, before finishing this topic, we're going to write some basic difference between spermatogenesis and oogenesis. Now, when the process will start? The process in male, the spermatogenesis start when? After puberty. So the process spermatogenesis in male starts after puberty. In female, oogenesis will start in the intrauterine life itself. in the intrauterine life. In the intrauterine life itself, the oogenesis will start. Okay. Number 2. Now, do you see a polar body formation in male? No polar body formation. No polar body formation. Here, polar body formation, yes. Now, next one. One primary spermatocyte. One primary spermatocyte forms 4 spermatid, whereas one primary oocyte forms only 1 ovum. One primary oocyte forms only 1 ovum. Remaining all are polar bodies. Okay, right. So now these are the points, basic difference between the spermatogenesis and oogenesis. Okay. Now we're going to write the answer for the high yield facts. Now certain high yield facts we have. Now we're going to write answer for this. Okay, number 1. The spermatogenesis completed in how many days? How many days will take? We have 3 answers: 74 days, greater than 64 days, greater than 60 days. Now, the secondary oocyte in the metaphase arrest. Secondary oocyte in the metaphase arrest waits for how many hours? I told you just now. 1 day, 24 hours. Okay. Next one. The sperms viable for how many days in the femogenital tract? 2 days. Very good. Sperms viable for 48 hours in the femogenital tract. So sperms viable for 48 hours. Secondary oocyte, the metaphase arrest waits only for 24 hours. So I told you the graphene follicle rupture and release the secondary oocyte and the metaphase arrest. Yes or no? Yes. That process is called ovulation. So now by these two ideas, these two datas, we can write the most fertile period. Now what is the most fertile period? 2 days before ovulation. 2 days before ovulation and 1 day after ovulation. 1 day after ovulation. That is the most fertile period. 2 days before ovulation and 1 day after ovulation. Why, sir? Because secondary oocyte in the metaphase arrest is ovulated and that wait only for 24 hours. After ovulation, only 24 hours is, yes, viable. So after ovulation, yes, we have only 24 hours. And sperm is viable for 48 hours. So the most fertile period is 2 days before ovulation and 1 day after ovulation. Is that clear? Yes. Now, another question. Now, how we know, suppose you got one patient for infertility, okay. Now, how we know whether ovulation takes place or not? Okay. So, we're going to see one case. Now, you are the specialist, infertility specialist. You got one patient, okay. Now, both husband and wife, they're married 2 years ago. They didn't use any contraceptive. So, both husband and wife, they are very much anxious to have a baby. Unfortunately, yes, the lady not conceived. So, they came to you for the further consultation, okay. So, now investigating both husband and wife, both are perfectly all right. Male, sperm count, motility, morphology, normal. His hormone levels are normal. He is not diabetic. Similarly, female, yes, her hormone profiles are normal. Thyroid profile is normal. She is not diabetic. No endometriosis, no PCOD. So, tubal patency is also normal. Everything is perfect. Okay. So, still, the lady is not conceived. Why? Because you are suspecting they are not mating at the right time. Now, you are advising them to have intercourse, mating at the most fertile period. You are telling them to have the mating, the most fertile period, that is 2 days before ovulation and 1 day after ovulation. You are telling them to increase the number of mating in these 3 days. Suddenly they have a doubt. Doctor, how we know whether ovulation takes place or not? See, if you ask the same question to Google or Siri or Alexa, they will say that during ovulation, the basal body temperature will be rising. Unfortunately, the couple is in Chennai or Hyderabad. The basal body temperature will be always high only. So, basal body temperature rise is not the indicator to predict the ovulation. Then how we know whether ovulation takes place or not? There is one hormone. Okay. Which hormone, sir? LH hormone. So, the LH hormone suddenly going for surge. It is called LH surge. Now, when the LH surge will occur? LH surge occurs 36 hours before ovulation. Okay. And the LH hormone is going for peak 12 hours before ovulation. If it is not given, then another best answer is at the time of ovulation. LH peak 12 hours before ovulation greater than at the time of ovulation. So now in pharmacies, LH patches available. Okay, you can tie the patch to the female's arm that may give a color change or give an alarm sound. So by that, you can predict the ovulation going to take place, and we can advise a couple to increase the number of matings in the fertile period. Okay, so few more points we're going to write. So in male, meiosis occurs in seminiferous tubule. Meiosis occurs in seminiferous tubule. Okay. Next, maturation of sperms. The sperms attain maturity in, you can write like that. Sperms attain maturity in epididymis. Epididymis. Okay. Capacitization of sperms. Capacitization of sperms. Capacitization means conditioning. Conditioning of the sperms. Okay, capacitization means conditioning. Conditioning of the sperms in the female genital tract. In the female genital tract. This conditioning will happen for 6 to 8 hours. Okay, right. So these are some basic points we have to know in the gametogenesis.